So in this lab, what we're going to do is we're going to take 3 resistors and we're going to put them in series. We're going to put them in one at a time so that we can look at the different voltages and currents that are going to power them. In doing that, we're actually going to be using these little light bulbs as our resistors. These will supply a steady resistance just like any other electrical component, but when they do that, they'll also produce a nice amount of light. And that'll be dependent upon the amount of current that flows through them. So we'll be able to get a really good visualization of the current going through them. So we're going to set up 3 different circuits. 1 resistor, 2 resistors, and lastly, 3 resistors. Now each of these light bulbs are going to be the same, exact same light bulbs, so they're all going to have the same resistance as well. So how are we going to set that up? Well, we have this nice little tool right here. This is called a breadboard. And a breadboard is an electrical stage where we can easily connect wires and things in a temporary fashion so that it very easily can be taken apart and tested, so we can try a bunch of different configurations and see what works before we solder anything or make anything permanent. The way this works is each of these sets of 5 dots here, 1, 2, 3, 4, 5, are all connected internally. So this would be like, bring this back over here, this would be like each dot would be one of these points. So I could have a dot where I connect my power source, a dot where I connect a wire. I can connect to that same dot, the dot right next to it, I can connect a resistor, and then another resistor, and so on and so forth. Let's see what that actually looks like. And just to start with, we'll use actual resistors, actual electrical components. This is what that looks like. This is a resistor. They're very tiny. It's made of carbon. And the whole point of this is to use up some amount of electrical potential so that we can get the right amount going to certain other components in the circuit. They serve a lot of diverse functions in creating circuits. So if I wanted to connect this, I would just put it in one hole and then put it in another. Okay, great. And if I wanted to connect another one in series with that, well, I've got this one's connected in this hole, so I need to connect it to something else in the same row in order to make that in series. So if I connect it there, and there, so now these 2 wires would be connected, just like on an electrical drawing. So let's break out the light bulbs. Let's set up our first circuit. We're just going to do a simple 1 resistor circuit to start off with. So instead of using a battery or plugging this into the wall or something like that, what I have here is an adjustable power source. This knob adjusts the voltage, and this thing is actually very fancy in that we can also manually adjust the current, so that if I wanted to, I could tell this thing, get to this level of current, and it'll adjust the voltage in that way. That's kind of uncommon, and normally we wouldn't use that, so we're just going to skip that part for now. We're just going to adjust the voltage. So the way this works is where a battery would supply a steady, constant voltage, maybe something like 3 volts or 9 volts or 12 volts, something like that. This can be adjusted anywhere from 0 to 30 volts. So all I have to do is clip the leads onto these wires, and when I hit the on button, it'll complete that circuit and it'll allow me to move electricity from this wire through here, through the light bulb, and back out here. So let's go ahead and turn it on. Let's see what our light bulb looks like just at a lower voltage. I've got the voltage all the way down to start with, and then I'm going to turn it up. We can see those numbers on the screen. Getting to about 2.5 here is where I want to hit. So at 2.5, the light bulb is nice and bright. We can see it. We can see that there. So If I turn it up, I can see that it gets brighter. With more current, I get more brightness. And if I got it too bright, it would burn out. So let's turn this off. Let's add in our second resistor, and let's see how things change. Okay, so we've remade our circuit with two resistors now. So this would be just like if we looked at it drawn out like this one. So we turn on our power supply. We'll turn up our voltage. Let's start by getting back to that 2.5 that it was at before. And we can see that our resistance is now 0.07 amps. And I don't know if you can see this on here, but these are very dull. The glow is very dull. If I turn this up to 5, what'll happen? And we see 0.12 amps again, our brightness is back up. We should see 0.12 amps when we double the voltage, because now we've doubled the resistance. Let's look at the math behind this. With just one resistor, we had a voltage of 2.5 volts, and we had a current of 0.12 amps, so 120 milliamps. So what was our resistance? Well, we can just take Ohm's law, take our voltage is equal to our current times our resistance, general form. If I want to find the resistance, I divide the voltage by the current. So take my voltage over current equals resistance. That's going to be 2.5 divided by 0.12. And if I do that, what I get is 20 ohms. Okay, so my resistor should be 20 ohms. Now, if I set up a second circuit that has two resistors, both at 20 ohms, what would be my total resistance? R1 and R2, both at 20 ohms. When I brought the voltage up to 5 volts, I got the current again at 0.12. Well, that should make sense because 20 plus 20 is going to be 40. That's going to be double our resistance over here. So our R total is going to be 40 ohms. And if I take Ohm's law again, V equals IR, but this time solving for current, V divided by R equals I, which would be 5 divided by 40 equals 1. And so we should see that that again would be 0.12. Perfect. So what would happen if we set up 3 resistors? Now in this one we've got our same power supply. My third resistor there looks like it's had a rough night. All 3 of these are equal to 20 ohms. And so my R total is going to be 60 ohms. Now if I wanted to get a current of 0.12, what would I need to set the voltage at? Well, I can set up Ohm's law. V equals IR. And this time it's just this form, just like this. So I'm going to take my current times my total resistance, and that should give me the voltage that I'm going to need to set this at. So total resistance, 60 times 0.12. Let's break out our calculators and do that math. We get 7.2. So about 7.2. For tolerance sake and for rounding sake, we can go ahead and guess if my initial voltage was 2.5 and I'm tripling my resistance, I'm probably going to have to triple my voltage. So it's probably going to be closer to 7.5. So anywhere between these two, and our predictions are going to line up really nicely. So let's go ahead and build it and test it out. Alright, I have my circuit set up with 3 resistors here. So now we can check and make sure that our actual math is actually working. So I've turned it on. We can see we're at 0 volts. Let's bring it up first to about 2.5 again. I don't know if you can see this, but there's a very dull glow. We're only at 50 milliamps. It's not very much current flowing through these. Bring it up to about 5. We're a little brighter, but we're not back up to where we were. So if I bring this up to, the math said 7.2. 7.2, and I'm at 120 milliamps. Just on the border there. It's rounding. Bringing up to 7.5, full on 120, and now we're at full brightness again. So what's the limit of these? How much current could these light bulbs handle, and what would happen if they got too much? Let's find out. Let's rebuild a circuit with 1, and let's crank it up. So if I turn this on, start pumping up the voltage. There's our normal 2.5, our normal brightness. Bring it up a little higher. We're getting pretty bright now. Do you think it's a matter of how much voltage can it handle, or a matter of how much current it can handle? It's getting brighter and brighter. This is significant. And then, all of a sudden, it's out. So at about 12 volts, our light burns out. When it does, it's getting a little warm. So we've got a bunch of energy trying to dump into this circuit, and it causes it to break apart. It's too much energy for that little light bulb to handle.